All right, hello everybody. Today I'm going to be teaching about finding area of parallelograms and rectangles. So here are the example problems. And I'm just going to go through this just like we would in class. All right, so let me grab a pen. This will be a little bit clunkier than usual. All right, so chapter 8, lesson 8.1, area of rectangles and parallelograms. Our goal is that we can apply the area formula for parallelograms. So remember, for a rectangle, the area formula is base times height. Ooh, this is fun. And a rectangle will have two pairs of congruent sides and 4 right angles. The base and the height can actually be interchanged, but typically the base is on the bottom and the height is perpendicular to that on the side. All right, now for a parallelogram, the shape looks like a rectangle, but it's slanted. And so we still have the base at the bottom, but the height still needs to be perpendicular. And so we have to draw a straight line down from the top, and that would be our height. You might also see it off to the side like this, and that could be the height as well. But because it's just a slanted rectangle, the formula is still the same, base times height. All right, so let's try some examples. In this first one, we have base equals 9 and height equals 4. Find A for area. So area equals base times height. So base is 9, height is 4, and if I wanted to put that on the picture, I'd have 9 here and 4 here. And then I just multiply those together to get the area, 36. Now, because this is an area or a two-dimensional space, we're going to have units squared. This does not have a particular label, so we'll just put U for units and squared. Okay, now if we're undoing the area, we're actually doing the formula with a T-chart or working it backwards. So again, formula is still the same. Area equals base times height. The base is unknown at this point because it says find B. So I'm going to put B here for the base. The height is 4 again. But this time the area is 24. And there's actually a typo here. This should be millimeters squared. So we're going to put the 24 in for the area. The base is going to stay a B. And then we're going to multiply by the height of 4. And here we're just going to do a T-chart. The opposite of times 4 would be to divide both sides by 4. And our base comes out to be 24 divided by 4 is 6. Now because of the label up here, millimeters squared for the area, that means the height would be in millimeters and the base would be in millimeters as well. All right, that's it for rectangles. Now if we go on to parallelograms, it's the same situation. Same formula, just plug in the numbers. All right, on this first one, base is 12, so that would go here. Height is 6, that would be perpendicular to the base. The second example, it says the base is 10, but then it says find H, so H for height. And the first one, we just plug them in. Base of 12 times height of 6, and then we would solve. For the second one, it's going to be a T-chart situation because the A is given, the area. So that would be 25 for the A. Base was 10. Oops. and height unknown. So this one's going to be a T-chart situation. All right, so for the first one, we're just going to type it into our calculator. 12 times 6, and we get 72. So this one has an area of 72 square units, and it does not have a label. So I will just put units squared. And on this one, opposite of times by 10 is to divide by 10 on both sides. And 25 divided by 10 is 2.5. Now if I look back up, whoops, that's a 0.5. This one had an area of meters squared, so this label would be meters. And that is our examples for today. Thank you for joining.